Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to solve radical equations where we have to raise both sides to a power twice in order to clear all the radicals. So what's different here in problem 9 is not just that we have two radicals in the equation, because we've seen that before. It's that we have two radicals in the equation and also a constant term. And that means that you're not going to be able to get rid of the radicals in one shot. So what we need to do is isolate one of the radicals first. So I'm going to add the square root of x plus 4 over to the other side. Square root of 3x plus 1 equals 1 plus the square root of x plus 4. Now that I have the radical isolated on the left-hand side, squaring both sides will clear that radical. However, I'm still going to have a radical left on the right-hand side to deal with. Well, one step at a time. Let's square both sides. The left side just becomes 3x plus 1. On the right-hand side, we have to multiply that binomial 1 plus the square root of x plus 4 by itself. And we're going to use that FOIL style multiplication, distributing. We still have 3x plus 1 on the left. Distribute the 1. 1 times 1 is 1. Plus 1 times the square root of x plus 4 is the square root of x plus 4. Then we distribute the x plus 4 through the second set of parentheses. Multiplying that by 1 is still square root of x plus 4. And then when we multiply the square root by itself, the square root disappears. That leaves us with just x plus 4. Okay. So we can see we still are going to have radicals left. We'll handle that in just a moment. Little cleaning up to do on the right-hand side. 3x plus 1 equals, I'm going to bring the x out to the front. 4 plus 1 is 5. And then we have two of those square roots. So 2 square root of x plus 4. I want to collect all the terms on the left-hand side, leaving just the radical term on the right. So I'm going to subtract x and 5 from both sides. That leaves me with 2x minus 4 equals 2 square root of x plus 4. I can divide over the factor of 2 as well. Sometimes you can do this and be left with no fractions. Like this case, sometimes you'll have fractions and you can just square both sides right now. But I'm going to divide over the 2 because 2 divides into each of those terms evenly. Continuing, scrolling this way. 2x over 2 is just x, minus 4 divided by 2 is just 2. And now we have the radical on the right-hand side isolated. So when we square both sides, the radical is going to disappear on the right-hand side. Let's square both sides. I need to multiply x minus 2 by itself on the left. And when I do that, I get x squared minus 2x plus 4. On the right-hand side, all I have is x plus 4. Scroll down a little more. Combine like terms on the left. X squared minus 4x plus 4 equals x plus 4. I want to collect everything on the left-hand side where the squared term already is. So minus x on both sides and minus 4 on both sides. I have x squared minus 5x equals 0. This one I can solve by factoring. X times x minus 5 equals 0. So either x equals 0 or x equals 5. Those are my potential solutions. So I've got to bring this all the way back up to the top and look at the original equation. So let me write those solutions here. X equals 0, x equals 5. We have to make sure that when we substitute those in, we get a positive number. So for x equals 0, I have to check 3x plus 1. 3 times 0 plus 1. That's 0 plus 1 or 1. That's positive. That's okay. 0 plus 4 is positive 4. That's okay. That tells us that x equals 0 is going to work. Same thing with x equals 5. 3 times 5 plus 1 is 16. That's positive. 5 plus 4 is 9. That's positive. And so both solutions here are okay. Our solution set is 0, 5. Now, what happened here, isolated one variable, squared both sides to get rid of that, isolated the radical that remained, square both sides to get rid of that, and then just solve the new equation. I have one more like this. The square root of 3x plus 12 minus the square root of 2x equals 2. I'm going to add over the square root of 2x to the right-hand side. Square root 3x plus 12 equals 2 plus the square root of 2x. I want to square both sides. Square root 3x plus 12 squared equals. And instead of writing this to the second power, I'm just going to write it by multiplying the right-hand side by itself. 2 plus square root 2x times 2 plus square root 2x. On the left-hand side, when we square that square root, we're left with the radicand, 3x plus 12. On the right side, we've got to use distributive multiplication, FOIL-style multiplication. 2 times 2 is 4, plus 2 root 2x. Distribute the square root of 2x through. That gives us another 2 root 2x. And then finally, square root of 2x times square root of 2x is 2x. Clean this up like last time. 3x plus 12 equals 2x plus 4 root 2x. Collect all. We want to isolate the radical on the right, so I'm going to move all the terms that aren't part of the radical to the left. Subtract 2x from both sides and subtract 4 from both sides. And that leaves us with x plus 8 equals 4 square root of 2x. Little bit of a problem here. If I divide over by 4, I'm going to have fractions when that happens. I'd like to try to avoid that if I could. So I'm going to square both sides. On the left-hand side, that's going to be x plus 8 times itself. On the right-hand side, when I take 4 root 2x and square it, I'm going to square each of those factors. So I'm going to square the 4 and the square root. On the left-hand side, distribute, collect like terms. What you're going to end up with there is x squared plus 16x plus 64. You'd have x squared, 8x, another 8x, and 64. I combine the 8x's together. On the right-hand side, 4 squared is 16, and the square root of 2x squared is just 2x. So that is 32x. I can now subtract that from both sides to collect all the terms in this quadratic equation on the left. X squared minus 16x plus 64 equals 0. I can try to solve this by factoring, and this factors to be x minus 8 times x minus 8 equals 0, and that gives me either x equals 8 or x equals 8. I only need one of those. So 8 is my potential solution. Let's go back to the top. X equals 8. I try it with 3x plus 12. 3 times 8 plus 12. That's 36. That's positive. That's okay. Try it with the 2x. 2 times 8 is 16. That's positive. So x equals 8 is going to work when we substitute this in, and our solution is 8. Now, the check that I've done here is just checking to make sure that it's not an extraneous root. I didn't actually check to see if it worked, but if we did that, what we just had, we would have had the square root of 36 minus the square root of 16 on the left-hand side, but that's just another way to write 6 minus 4, which is 2. So it checks, the arithmetic checks as well. When you have two square roots and another term or more, Isolate one radical, square both sides. Isolate the other radical, square both sides. Solve what you have left, and then check. All right, in the next video, we'll move on to a different type of problem.